to get to the workpiece as the process takes place. And how that makes the cut go faster is if the machine is trying to maintain a big gap, exaggerated, like this, you will have instances where the electrode is too far away for a spark to be discharged, so it doesn't make it across the gap and do work. But if you're using a compression that's lower, it means that you're pushing the electrode closer, and that means that every spark that's supposed to make it across the gap has a better chance of doing so. However, what's a better flushing condition? When the electrode's this far away, or when the electrode's this far away? It's when it's higher. So, again, the better you can flush with either the side flush or through the electrode, you're going to be able to manipulate these better. You follow? If you don't have good flush, you're not going to be able to manipulate them very well. You know what I mean? You may have that, what is known as a DC arc. The DC arc is just a short circuit that never goes away, and then you basically weld your piece. Have you ever had that? No? I wish I could say that. I wish I've never.
What happens when you weld it?
You ruin the workpiece. You know, like I said, you know, you could put like 30 to 50 thousandths deep, you know, pits in things, and that could just ruin it. You know, if it's a mold insert that has to be polished, you'll never polish that out. You'll have to actually put weld in there and reburn it. You know, so it's just something that you have to. And then finally, to help you flush, is that cycle timer is over here. The cycle timer, if I click on it, you could have the cycle timer being off. What that means is when you have the cycle timer off, the electrode stays down there and it doesn't pulse. Remember we were watching this over here and it was pulsing up and down to help it flush? If you turn the cycle timer off, it stays down in the cup.
Why would you ever do that?
Well, you would do that if you had good flush.
Oh.
You know what I mean? I mean, because then you're not. Every time you back out, you're not doing any work. You know, every time you retract the electrode, when you're up here, it's not burning. If you could keep the electrode just burning the whole time, that's what you want to do. But you'd have to be flushing through the electrode to allow you to do that. I mean, so why would you do that? You would do that only if you were like I said, flushing through the electrode. But you have a couple of things related to the cycle timer. A downtime, which is from 0 to 9. That means how long. I think it's in microseconds, isn't it? Yeah, 0.1. It's not microseconds. It's each unit here represents a 0.1 of a second. So if you say 99, it's going to stay down there as long as it can with the cycle timer on. The up is how long it stays out of the cut for. So you want to go as low as possible with that, because every time it's out of the cut, it's not doing any work. And then the speed of the timer is how fast that moves in and out. 0 is the fastest. 10 is the slowest, or 9 is the slowest, not 10. So it's 0 to 9, it says that right there. 9 is the slowest. So to go as fast as it can go in and out, Let's say 0. It's set to 1, by the way, as a default. The polarity is what the head or the electrode has for a charge. So the electrode has a positive polarity and the workpiece has a negative polarity. You'd only change that if you were burning certain materials, like carbide. Carbide would go with a negative polarity. So, I mean, to answer your, I think your question earlier was, what can I manipulate to go faster? It's really flushing and these two values right over here that you can manipulate to try to go faster. Or, I mean, if you're not worried about your size or your finish, you could change these two things too. Now, you asked me something earlier. What's the difference between automatic erosion programming and just erosion? All right. So if I at the bottom of this program I say add, and then it comes up with this screen again of everything I can choose. If I say erosion, and I say OK, it's asking me for a number here, which again I'd have to pick out of
321.
321. I'm going to go with that. Well, it goes to, this is your database right here, which is basically the book thing. So if you go to fine graphite to steel, standard values, which it is, 321 right there. Once I hit that, it goes into the setting right there. Then I have to put in what depth I'm going to. Z minus, and what kind of orbit I want. Put in the radius. Say OK, but it's only doing one setting there, whereas the automatic setting, the automatic programming, gives me a rough to finish. You follow what I mean? Does that make any sense?
That just won't be a good job. It'll be done quicker probably.
But it will not, yeah, I mean, if you're just like burning a hole out, for instance, you know, you're putting a hole in something, you're not concerned about a real good finish. You're just trying to get through it, right? So that may be a case where you just call up one erosion.
Well, or what if you went through this whole first one and you realize, well, my hole's, a tenth too small. Could I just go and do that and just come in and kick that last?
Well, all right. So this is what you'd want to do. If you ran this program, right here, and you found out that it's too small, you got to orbit it out a little bit more. You could go back to AEP, right? Right at the top, say edit. Go into orbit data and then just change that right there.
Okay.
So it's 7.5 now. You just burnt with it. You found out you're too small. That's going to open it up 5/10 aside or 1/1000 overall. If you don't want that much, you could go in there and make it like 7/8, which is 6/10 overall, 3/10 from 3/10, you know, and then just say OK, and then run the program over it.
But you'd be starting from the top.
Which I know what you're thinking. You're thinking, why would I want to go through all those settings? It's not going to take that long to buzz through those settings. But if you don't want to do that,
So it's not going to take the same amount of time?
no, it won't. No.
Oh, okay.
If there's no material there, it just goes right through it.
Oh, okay.
If you don't want that, you can easily just come down and say, I want to run the last setting,
Yeah.
set start.
Oh, okay.
Right, it'll just come right down to that.
Right.
That was my, if you wanted to make it go a little bit deeper, you would just add in that, what would you do then?
Okay, if you want to go deeper again, you're going to go back to edit, right at the beginning. This number right here. If you want to go 5/10 deeper or something like that. Right? Say okay. And then just run the last setting again.
Okay, just run the last. See how
As long as that last setting is less than, the change is less than the depth of the last setting.
Right. You got to go deeper.
Yeah.
Is that what you were saying?
Well, so the last setting is going to do about 0.03 of an inch.
It's going to stay away by.
Would you have to go to like setting 5 or?
No, you don't. You don't have to go. You can go right to that. You can go right to that number.
So whatever that, when it goes from 6 to 7, there's 6 is leaving a certain amount per 7. Right?
Yeah.
So as long as you want to change it by less than the difference between 6 and 7.
But it doesn't. It's not reading 6, so it doesn't care what's in 6 now. Do you follow? It's gonna. Here's.
Okay. All right. So it senses when it's doing work.
Right. Right.
Okay.
Yeah, it
so
senses-
not like these machines.
Yeah. It senses.
Okay.
It senses. I mean, you're saving. You're probably saving by doing that. You're saving maybe a minute.
Like
Because
you said,
there's no
it's
material there, so it just buzzes through the settings. Maybe a little bit more than a minute, maybe 2 minutes. I don't know, but it's not a lot. It's
Yeah.
not a lot that you're really gonna notice a difference. Like, oh my God, it took 20 minutes to burn to this point. Is it gonna take another 20 minutes?
Right.
No.
Yeah. Okay.
It's if there's no material in its way, it's just gonna buzz right through those settings, and then if you're only taking out 5/10 or thousandths or whatever, but position, you could do that running that last setting. Just got to make sure you're in position to do that.
All right. It makes sense.
So, are we all right with, because we're way ahead of where we should be. If you guys are understanding this so far, either I'm an excellent teacher or you guys are
tired.
new. I would just call it I take the P. 3 points. And we say add, and we still do the automatic erosion programming. We still do it the same way that we've been doing it, you know, Z minus, the depth, the surface finish. Again, you know, the square inches, you have to figure out what the area of what you're cutting is. Whether it's copper to steel or fine graphite to steel. Minimum wear or standard values or maximum removal, and then the electrode undersize. And again, that goes back to planning out the job. So you would come to your fine graphite to steel. I keep on losing that page, but so we come to the fine graphite to steel. Standard settings, and when you're planning out the job,
Go ahead.
thank you. You look at that, like in this case, it's 0.77. So let's put in there now. Let's put in there 0.6. Go right to the book. 0.62. I got something that's 0.62 square inches. So I look in the book, and lo and behold, it says, all right, my first setting is 331. And my electrode undersize should be at least 13 4/10 total undersize that I make my electrode. And that's the safe 2-gap. So I'm going to make my electrode 14 thousandths under, at least 13.4, make it a nice round figure. I'm going to make it 14. So I answered everything on this page right here. Now I go to erosion points, and it's a little bit different where I say, from my zero, from the 0 point, where is this first location? Up here in the upper left-hand corner. So let's say it's minus 0.2, 0.2 up. Number of rows, let's say is 1. But the columns, I got 3 columns. And the column spacing is 0.5. So that means I got 1 row, but I got 3 of these spaced out ½ inch between them.
That's,
Huh?
so that's not a ½ inch move. There's a ½ inch between?
It's a ½ inch move. Maybe I make it a little bit more than that, right?
Well, so whatever
Whatever it is.
Yeah.
Yeah, it's a half.
But
It's like, so it started at this location from my 0, but now I'm going. Keep it up above the part by 50 thousandths. ½ inch over, ½ inch up. The spacing is 1 inch apart. Now go to orbit. That's fine. Once I say OK here, so I wrote the program. It says move to work point 1, do the erosions. Move to work point 2, do the erosions. Move to work point 3, do the erosions. So I wrote the program for 3 different spots. If I want to look at those work points again, I can come over here. All right? Go there. And go into name. And it shows me a little chart of where they are. Back to the program. So one thing that it did show there, get rid of those work points now. Hold on a minute. Go to work points. I'm going to get rid of these. I got to get rid of these. If I want to rewrite the program, I got to get rid of the work points. Go back into program, edit.
So I was doing erosion 1 on all the...
Yeah, I don't know if you see this, how it did it. The last way it did it was it did, on each work point, it finished it. It did rough to finish, right? And then it moved on and did rough to finish. And then it moved on to the last one and did rough to finish, right? It did all the erosions. Now, it's running each erosion through the workplace.
You
All
get
that's,
better-
all that's doing is it's making it more uniform wear, so you're not wearing out your electrode. By the time you get to the third one, if you're using the same electrode, right, that cavity is going to be much smaller than the first cavity. Whereas in this case, they'll all be this approximately the same. So where that was again was when you go to edit. I clicked on that rather than that. That's the only difference. All right. All right. I need another break if you don't mind.
Don't mind at all?
这个怎么弄？
就用手指指看看就得了呗。